Hello, and welcome to the next video in my series on basic statistics. Now this video is actually an extension of the previous videos I have done on the chi-square. The difference of this video is that we're actually going to go into SPSS and learn how to define our variables, how to code them properly, and then how to solve our chi-square using a special technique that allows us to use the chi-square by only having the contingency table. So let's go ahead and dive right in. Now we have the same problem we did in the previous videos. We work in the Office of Institutional Research at a small but growing university, and over the past 5 years the number of undergraduate students at each level, so freshman, sophomore, junior, senior, and then an unclassified group, has changed. So over the past 5 years we have had headcount variation, which we would expect. Now the questions are, even though some headcount random variation is expected because our headcount is not going to be the same every year, is the variation beyond what we would expect due to chance alone? Now how can the chi-square test help us rule out variation due to chance alone? And how can we use SPSS to conduct our chi-square test? Now in this video I am not going to review the nuts and bolts of the chi-square test. I did that quite a bit in the previous two videos. So if you want to learn more about the chi-square itself, go ahead and watch the two previous videos before doing this one. So here is our contingency table for our data. Along the top we have the 5 years, so 2007 through 2011. And on the left hand side we have each grade level, so freshman, sophomore, junior, senior, and unclassified. So again, this is the contingency table that we will use for our chi-square. Now to use this in SPSS and other stats programs for that matter, we're going to have to develop a coding scheme. Now what I've done, if you look along the top, each year is given a number that we're going to use to code it in SPSS. So 2007 will be coded as a 1, 2008 will be coded as a 2, so on and so forth. On the left hand side we do the same thing for our grade levels. So a freshman will be coded as a 1, a sophomore will be coded as a 2, junior 3, and so forth. So we're going to use this coding scheme to actually define our variables in SPSS and then type in the data so we can go ahead and do our chi-square. So let's go ahead and go into SPSS and do that work. Okay, so here we are in a fresh, newly opened SPSS file. And just for the record, I'm using SPSS version 17. Now the first thing we want to do is define our variables. So we're going to go down to Variable View, which is a little tab along the bottom, on the bottom left. And here we are in our Variable View where we can name and define our variables. So again, we want to make sure this meshes with the coding scheme we developed in the PowerPoint part of the presentation. Alright, so the name of our first variable is going to be year. So this will hold the 2007, 2008, and so forth. So this will be a numeric, because remember we coded it using numbers. And the label we'll just call year. Now, probably the most important thing here besides the name of the variable is the values. So we got to define our coding scheme for the year variable. So we'll click on the little ellipsis there on the right hand side, and this brings up our value labels. So this is where we tell SPSS what a certain, in this case, number means sort of in real life. So we're going to assign the value 1 to the year 2007. Then we'll add that. The year 2, sorry, the number 2 to 2008. We'll add that. 3, 2009. 4, 2010, and 5 will be 2011. So now in that field, when we type in the data, we will just use those numbers, those single numbers 1 through 5, to represent the years 2007 through 2011. So we'll go ahead and click OK. Now on the right hand side, I'm also going to change this to a nominal variable because the years are actually nominal. So 2007, 2008 is each a sort of a categorical or nominal year. Okay, so the next one will be the grade level, which I just called grade. That'll be numeric. We'll call this grade level. Now I'm going to assign this to values. So 1, let me move that up, will be freshman. So we'll add that. 2, sophomore. 3 will be junior. 4, senior. And 5, unclassified. So that's kind of an other group. So there we go. So 1 through 5 represent our actual grade levels. Click OK. And again, I'll change this to a nominal. There we go. Now the last variable is actually the number of students we're going to have for each one of those combinations, those pairings. So I'm going to call this frequency. That'll be numeric, of course. This will be student head count. Now there are no values for this because it will just be the number of students. We're going to leave this at scale, okay, because that actually represents the fact that we're counting the number of students. So there are 3 variables. Year, coded as 1 through 5, representing 2007 to 2011. Grade, which is actual grade level. So that's coded as 1 through 5, representing freshman, sophomore, junior, senior, and unclassified. And then frequency, which is actually the head count for each pairing of year and grade, just how it looks in our contingency table. So that's all we have to do for defining our variables. So let's go ahead and type in our data. So I'm going to switch over to data view. And you'll see there at the top, we have year, grade, and frequency. Now this follows a very easy pattern. So what we're going to do is for year, we're going to go 1, 1, 1, 1, 1. Now what does that mean? Well, those are all the year 2007. Now over in grade, I'm going to go 1, 2, 3, 4, 5. So what does that mean? Well, if you look at those as a pair, for 2007, we have 2007 freshmen, we have 2007 sophomores, 2007 juniors, 2007 seniors, and 2007 unclassified. So we're just going to repeat this pattern all the way down through this data set. So 2, 2, 2, 2, 2, 3, 3, 3, 3, 3. Okay, so we should have 25, because remember we have 5 years and 5 grade levels. So 5 times 5 is 25. Now we need to repeat this pattern in grade. So 1, 2, 3, 4, 5. Remember, I can also select those, Control C, at least on the PC, and then paste. And there we go. So that matches our contingency table from the PowerPoint part of this video. So for each year, we have all 5 grades, all the way down. Now all we have to do now is type in our head count for each combination of year and grade. So I'm going to go ahead and start doing that, and I'll pause the video, fill in the rest, and then restart the video. So this was 560, 369, 209, 267, and 64. Okay, I'm going to go ahead and pause the video, fill the rest in, and then I'll be right back with you. Okay, so we've gone ahead and typed in the enrollment data for each year and grade level combination. Now it's important to remember here that in statistical terms, each case is a row in our data table. Now each case in this example is defined by a year and grade combination. So each case in this data set is not an individual student. It's a year and grade combination that has summary data that is a certain number of students, but it relates to our contingency table from the previous part of the video. Oftentimes, that's all we have to work with. So if we only have the contingency table, this is the method we have to use in SPSS to do the chi-square. So that's why we kind of call it the down and dirty method, because we're actually using the statistical summary in our contingency table. Now before we do that, we have to do one necessary and obviously important step. We have to weigh our cases by the student head count. Now the way we do that is we go up to Data, we go down to Weight Cases, a little dialog box pops up, and we need to weigh our 25 cases by the student head count. So we'll select the Weigh Cases by radio button, make sure we have student head count selected, we'll move that over, and that puts it in the frequency variable box. This should make sense. That's why I named this variable frequency, because it asks us, okay, which variable is your frequencies? So that is student head count. So frequency variable is student head count. All right, so we'll go ahead and click OK. Now the SPSS output box pops up to let us know that we are in fact weighting our cases by frequency. I'll go ahead and minimize that. And now we're actually ready to go ahead and do the chi-square. So in SPSS, using this form of data analysis, we're going to select Analyze, go down to Descriptive Statistics, go over to Crosstabs, and we'll select Crosstabs. This is actually a fairly simple box in this case. So for rows, we're going to select the year and move that over. For columns, we're going to select grade level and move that over. And this should make sense. Think about our contingency table in PowerPoint. We have rows and columns. You know, one row is the year and the columns is grade level. Now in this case, it really doesn't matter which one you put where, because in the end the totals will be the same. So just move one over into rows and one of them over into columns. And of course our frequency stays over there on the left hand side. We're not going to use that in this dialog box. Now we have to tell SPSS to actually do the chi-square. So we'll select Statistics. A little box comes up, and in the top left you will see chi-square. So we're going to check that box. Click Continue. And that's it. So go ahead and click OK. And there we are. So the crosstabs comes up. We have a case processing summary. It just tells us how many valid cases we had. And remember, in this case, it was 7,715. Now in our contingency table, that would be the lower right hand cell, which is the total of each column in the row, the total column and row. Now the year by grade level cross tabulation is actually a repeat of our contingency table. Now if you notice, the year is on the left and the grade level is on the top. That's just because I switched them in the crosstab box. It doesn't matter, okay? Because the sum is going to be the same regardless of which orientation it is. Now, of course, the most important box is the chi-square test at the very bottom. If you notice, we have Pearson chi-square of 46.781 with 16 degrees of freedom. Now, if you remember from the previous video, that's exactly what we found when we did the chi-square by hand in Excel. It was 46.781, or approximately, 7.781. There's going to be a little rounding error in there somewhere. Degrees of freedom. Remember, degrees of freedom were just the number of variables minus 1 times the other number of variables minus 1. So 5 minus 1 is 4 times 5 minus 1 is 4 again, which is 16 degrees of freedom. Now the significance in this case is 0.000. So that is obviously below 0.001. So this test is statistically significant. So what we can say here is that year and grade level are not statistically independent. There is some relationship there, a very significant relationship statistically. And that's all we can say. We can't really say any more about that relationship or make any subjective judgment about that relationship without some theoretical background. But statistically, all we can say is that these two variables are statistically not independent. They're statistically related. Let's go ahead and go back into PowerPoint and finish up our video. Now here's just a quick review of what we did in SPSS. Of course, we defined our variables and then ran our tests, but I just want to go through the steps so you can go back and look at those if you need to. Once we had all of our data typed in, the next thing we had to do was weigh our cases. And this allows us to use the chi-square test only using the contingency table data. So in our example, each case in SPSS was not an individual student. It was actually a combination of year and grade level. So instead of having 7,000 students in our case list, we just have a combination of year and grade level that corresponds with our contingency table. Then we can do the chi-square. But we have to weigh the cases in our frequency variable so we can do that. Now, of course, to go ahead and do the chi-square, we use the cross tabs feature in SPSS. So on the left-hand side there, you can see that we only had 3 variables, and we moved year over under row, and then we moved the grade level or grade over under columns. So we're doing a cross tabs of those 2 variables. Now under statistics, we selected chi-square, which is the top left box, and really that's all we need to do our chi-square. So what were our results? Well, the SPSS output shows us that the Pearson chi-square value was 46.781. Now, if you remember, this was the exact same value we got when we did the chi-square by hand in Excel in the previous video. It's the exact same value. Now, of course, we have 16 degrees of freedom again, and then our significance is 0.000. So that means it is very statistically significant, below the 0.001 level. Because it is significant, we must reject our null hypothesis and conclude that grade level and year are not independent. Because remember, the chi-square is just determining whether these 2 variables are independent. We're not making any subjective conclusions about what that relationship is or anything. We're just saying they're not statistically independent. So what we can say is the difference between what we expected and our observations were just too great to be explained by chance alone. So that's how we do a quick chi-square in SPSS using just the contingency table of data, which is what we have most often. Just remember, you have to weigh the cases in your frequency column before you can do that. Thank you so much for watching, and I look forward to seeing you again in our next video.